I wanted to now hop into a little bit of a demo where we can actually see the 802.11ac kind of captures and what's going on there. So I'm just going to come up and share OmniPeek instead. So hopefully we are all seeing OmniPeek. And so what are we actually doing right now? So as I mentioned earlier, if that picture was still left in your mind, that's essentially the setup that I have running there. It's actually the identical setup. It's the same laptop on the same desk with mostly the same adapters attached to it. But I do have now two other adapters attached to my laptop. So let's just pretend for the moment like we were going to go do a new capture, and then I can show you what those adapters are that are attached to my laptop. So you can see here, there's one highlighted, the IO Data 11AC. This is another adapter that's attached to my laptop. It's basically the same Cisco AE6000 device that you saw in that little picture. It's actually just made by a different manufacturer, but it's essentially the exact same device. Because I'm actually using the Cisco AE6000 to actually send the data. That's why you don't see it in the list here right now. So I'm using that to actually capture my traffic. And right now I'm actually doing a live capture with 802.11ac. You can see that by number one, by the packet counter pair, packets received, and packets filtered is constantly going up. This capture is ongoing. I do have one right next to it that I had captured overnight last night. And I did that just to make sure that there was traffic, just in case there was any problems this morning with the live capture. But the live capture's on and has been going in some time, and we're looking at this live capture within our Compass dashboard. So let's pretend one more time like we're going to go start a capture, and let me bring up one other point about this adapter. So this is the adapter that I was using, like I showed. One of the key things here with capturing AC, right, is in capturing, knowing how things are configured, right? So as we've gone from, BG to A to N to AC, the options for capturing data just continue to expand. So, let's just, before we go to the channel that we're actually on, let's just choose, for example, channel 130. You look in here, we see this channel 132, right? So we have 132 AN and then 132 N40 high. So what does that mean? So 132 AN means I'm going to capture on channel 132, and that's the traditional channel 132 with a center frequency at 5.66 gigahertz, with the traditional 20 megahertz of bandwidth, right? Then let's say, I want to, actually do it in N, but with 40 megahertz. Then I would move to the channel 132, that's center frequency at 5.67 gigahertz, right? N40 high. And let's say it's AC traffic, right? Well, my AC traffic, is going to be back here on channel 128, because the AC traffic isn't available on all the channels because of the channel bonding. It's just available on some of these channels like this. So you can see there's many, many options. So here today, I'm sending the data, channel 165, we're sending the data on channel 161. So again, on 161, I have three options, right? I have my AN option, my traditional option for 20 megahertz bandwidth, A or N traffic. I have my 40 megahertz bandwidth option for my N traffic, right? Or I have my 80 megahertz bandwidth option for my AC traffic, right? And you can see, three different choices. And where we're capturing at today is right here, right? It's 161 AC. If I don't set it to AC, my bandwidth will not be wide enough to capture the data that I'm actually transmitting right now, because I'm using an AC device and that's defaulting to 80 megahertz to send the data. So that's how this capture is running. And what I'm actually doing in this is I'm actually running ping traffic back and forth between actually the same laptop that's doing the analysis. Not recommended typically, but it's what was available to me today. And 802.11ac access point. The access point is actually capable of two-stream operation. But since the device, the wireless LAN adapter that I'm actually sending the traffic through is only a one-stream device, it's going to default to a maximum capability of 466 megabits per second. So how do I verify, number one, on my Compass dashboard that all this is really going on? Well, one of the things that I can do first is I can come down to this lower right-hand corner where it says channels, and I can see, right, I'm capturing data on A, right? And I'm also capturing data at AC. So why is that, right? I just said I was sending data on AC. That's what my ping traffic is. Why am I capturing all this A data? Well, because it's only one AC station that I have, right? And the access point, even though the access point is designed to operate at two-stream AC, that access point has to remain backward compatible. Anything that it sends from a management perspective has to be sent, back in a traditional format, 20 megahertz, channel A, 161A, so that any 5 gigahertz client can see that access point beaconing, for example, so that anyone can see the clear to send and the request to send messages, etc. All that has to be done at a level and at a data rate that every client can understand. So that generates a whole bunch of what looks like A traffic, right? 4 times as many bytes as I've sent or that have come in, as with AC. That's where all that's coming from. And how do I know that? Well, I know that by coming over to the left-hand side to the protocols area, right? I've sorted this now by maximum bytes in. You can see my ICMP echo repo, my ping traffic, right, is at the top of my list. But below that is all of this other management traffic, right? Block acts, manage per request, request to sends, clear to sends, ARP requests, DHCP protocol stuff, all of this stuff, and this is all done at A. So, even though I'm capturing at AC and I'm capturing AC data, I'm also capturing A data at the same time. And that's, of course, the way it has to work and the way it should work. So often the question arises, well, gee, if I have an AC adapter, and I'm capturing that way, am I going to get my HF? Am I going to get my management traffic? You absolutely are. That's exactly what we're getting here. Again, I'm capturing on one and only one device, an 11 AC one stream device, and I'm capturing all of my management traffic on A as well as the specific AC traffic. So there's where we go with that. So to get a little bit more of a view of that, we can go to our wireless LAN view, and you can see that's exactly where we are. The wild bright AC, that's our access point, right? And then here's my station that's actually connected to it, and we can see what's with basically that through the wireless LAN protocol. We could come to our peer map, and we can see, essentially the same thing. Here's my access point, and here's my client right here. I can scroll over there, and you can see most of what I'm sending is ICMP echo replay data, right? There's a little bit of destination unreachable stuff, some DNS and DHCP stuff, but basically, this is the major bit of traffic that we're following right now. So, what does all this look like now? A layer down. Well, one more thing, just look at real quick, is I want to show you in the protocols, right? So we can see in the protocols, here's our replay data. But as I mentioned, right, there's all this other A data, right? Probe responses, beacons, right? Probe requests. So all that factors into the data, right? So again, we're going to see that kind of mix like we saw. And, back to Compass one last time, what does that mean for other things? Things like data rate or other things? Well, if we go to data rate and we choose our, we can see now what our average data rate is, already pretty high because of all that AC traffic. And if I get rid of the total, and then come look at, perhaps just my ping traffic, we can see, what that looks like. So here's my node that's sending all of the ping traffic. If I come here, now we can see our average data rate for this ping traffic, even though we could hit as much as 466, our average is really around 300. Every now and then we've got some that are up around 360, right? But you can see this high data rate that we're getting when we look at just the ping traffic, right? That we go back to our total and then stretch it out that way. So there's our data rates, and those are the average data rates. I'm sure if we went in there and looked at peak, we'd see things a little bit higher through there. So what does this look like from a packet perspective? What if we were actually now wanted to do deep dive into packets? Well, you can see we're still capturing all those packets they're scrolling by. We'll stop the scrolling because it probably doesn't work for you guys or work here. Let's look at a few just in particular. Let's just go take a look at a beacon, right? So if we go take a look at a beacon, we'll double click and we'll bring up the decode for the beacon. Not terribly different than what you might have expected today. And again, because it's a beacon, right? Where's this going to show? It's going to show as A data, as an A packet, even though we're looking at AC, because it's sending out the data at 161 at the traditional center frequency for 161 at a 20 megahertz bandwidth at 6 megabits per second, so that every client can understand it. So it's going to look like A traffic, right? So and then we can see all the things that are reported in here, et cetera. I'm very close to the access point. My signal strength is very, very high, in terms of signal strength, signal level 100%, right? So we're right up near the top. So as we scroll down, this is going to look like any other beacon would have looked to you all the way back from the original, BG days, et cetera. It's only as we get further down in the decodes that things, newer things, start to come in. Now, if you've dealt with any 11N, and you're probably even also familiar with what we're looking at right now, from the screen on down, that's the high throughput, the HT capability info. This is all parts of the beacon that have been decoded that talk about what the access point can do from an 11N standpoint. What are its 11N capabilities, right? So we can see all of that for just here in the beacon, right? So you can see all the different rates, et cetera, that are supported. How many streams, et cetera, right? So as we go down, more high throughput, even more high throughput. Then we get to a new area, VHT, very high throughput. This is now where we're now decoding things about that access point that relate to 802.11ac, right? For example, we get into this kind of area, right? Down, about toward the middle in the decodes, right? Short GI for 160 and 80 plus 80 not supported, meaning that this access point is not going to go into the 160 megahertz bandwidth, but it is supported at 80 megahertz, right? We can see if things like STBC are supported, right? We can see if LDBC is supported, right? So all of these, newer things that 11AC offers, we can see where all of those are as well. And again, all of our data rates as well. Down as we get the operational element, right? We can see our very high throughput operational information. Our channel width is at 80 megahertz, et cetera. So we see what our transit power envelope is. All this that's new in 802.11ac. So it's a lot of new information, even in the beacons. All this decoded, for us by OmniPeek. So there's kind of one level, again, capturing this AC traffic. Let's take a second and go look at one of the ping packets themselves. So here's one of the ping packets. Again, we're not going to see as much decoded info in there because now this is a data packet, right? So it's mostly about the data. So where we're going to find most of our interesting information right now, about this packet is up in the packet header information. This information that's up in the top in green, where we can see things like our MCS index, right? The spatial streams that were used, what data rate that equates to, what our channel is, and then as we get further down, what our bandwidth is, whether it's aggregated, whether we're using long or short GI, what our signal level is. We'll even break the signal level down for each of the three for the individual streams. If they are used, these aren't used. That's why they're low. So we can see our overall signal strength at negative 41. So here you can see, as we decode that the ICMP packet itself. As we get further down, you can see it's actually it's the ICMP packet, right? You can see the data that we're sending in the packet. So there's the data. So again, with OmniPeek, we are able to take and decode all of this 802.11ac traffic, break it down in all of the various views, whether it's in the packet view and the other view, it doesn't matter, all of that available to us. Some of the things like we saw in the packet that we're porting even right back in the packet view. When of course we see our data rate, we see MCS when it's available. So when it's an 11N or an 11AC packet, we will see MCS values. We will see the number of spatial streams. All of this decoded as part of what we're doing. So you can see the capabilities to capture 802.11ac traffic are there today. One stream today, if you're doing it with a USB device, two stream or more, if you actually use an access point to capture the data, which is one of the other approaches that I discussed as we went through here.